So hi guys, so karon kay mag-discuss ko about analytical chemistry. Particularly ang introduction ra og ang gravimetric method of analysis na part. So for the introduction, let us first define what is analytical chemistry. So it is the branch of chemistry that deals with the separation, identification, and composition of matter. It involves the application of techniques and methods to obtain and assess qualitative and quantitative and structural information on the nature of matter. So it is analytical chemistry is divided into two. So we have qualitative analysis and quantitative analysis. So for qualitative analysis, it is a type of analysis that reveals the component of the sample. Then for quantitative analysis, it is a type of analysis that determines the amount of components present in the sample. So basically, qualitative analysis answers the questions what? Unsay sud sa ato ang sample. Then quantitative analysis kay it answers the question how much? How much? Kung pila ang sud sa atong sample, pila ka analyte or pila ang kanina component sud sa atong sample. So yeah. Next, so there are different types of analysis and it can depend on the technique, then amount of sample, pila ang atong sample, and extent of the sample. So when we say extent, kung asa kutob ang ato ang pag-analyze ana na sample. Ingana. And lastly, we have amount of analyte. So for the technique, it can be classical. So example of which kay gravimetric na method and titrimetry anang classical. Then an example of then instrumental examples of which kay ang kanang pag-use og UV, chromatography, spectrometry, spectrophotometer, pag-use og kanang mga machines, instruments, ingana ang instrumental analysis. And we also have combination of the instrumental and classical. Then for the amount of sample, it can be kanang micro scale, semi-macro or meso, micro, and ultra micro. Then for the extent of sample, it can be proximate analysis, complete analysis, and ultimate analysis. So I think na encounter nato ni ang kaning proximate, complete, ug ultimate dinha sa ato ang check-up 2 katong combustion. So for the proximate kay gipangita niya ang VCM, volatile combustible matter, FC, ash, og moisture. Then for the ultimate kay gipangita niya ang individual na mga components gyud, like for example, amount of carbon in our fuel, pila ang percent nitrogen, percent sulfur dinha sa ato ang fuel, so ingana sa ultimate. And so for the complete naman kay I don't know kanang unsa ni siya, so pwede ninyo i-search baron i-search ninyo ang sa complete. Then for the amount of analyte, how much analyte ang naasud sa tong sample in terms ang analysis ana. So it can be major, minor, trace, ug ultra trace. So for the next slide, I have here a table of ranges sa ato ang types of analysis in terms of amount of sample ug in terms of amount of analyte. So for the amount of sample, if ever greater than 100 milligrams ang atong sample, it is considered as macro na analysis. If ever 10 to 100 milligrams kay semi-micro, then if 0.1 to 10 milligrams kay considered siya as micro-analysis, then if ever less than siya og 0.1 milligrams kay considered na siya as ultra-micro. Next, for the amount of analyte, if ever gani greater than 1%, ang kanang WWDA guys kay mass percent na siya. If ever greater than 1% siya, so it is considered major na analysis. If ever 0.01 to 1% kay minor. If ever 10 to the power of -7 to 0.01%, it is considered as trace analysis. And if ever less than siya sa 10 to the power of -7%, kay ultra trace na siya. So next. So before proceeding to the other types of analytical techniques ug ang gravimetric method, let us first look onto kanang mga terminologies, mga terms na atong usually frequently na ma-encounter sa analytical chem. So we have the analyte. It is the component of interest in the sample. We also have matrix. It is the collection of all the components in the sample. So the relationship between the two is that the analyte is part of the matrix. So just a matrix ang analyte. So for example, we have lead in soil. Nag-analyze ta og lead sa soil. Nag-analyze ta og lead sa soil. Okay. So ang analyte nato ana kay ang lead nya, ang ato matrix kay itong soil. Another example kay analysis of mercury in our tap water. So ang atong analyte there kay ang mercury and atong matrix kay atong tap water or atong water. Okay? Next, we have procedure. It is the set of written instructions on how to apply a method to a particular sample. Then we have sampling. It is the process of collecting a small amount of material whose composition represents the bulk of the material being sampled. So example here kay sa mining industry, di ba ang ilahang mga raw material kay mga dagko man kayo na ores. So dili man pod pwede na ang dagko na ore ang atong i-analyze or ibutang dito sa lab. No. We will just get a small part ato na mga ore or kato na bato niya mao to ato ang i-analyze. So ginagmay lang. Okay, same raman gihapon na ang iyahang component. Okay. Then aliquot, it is the portion of a solution subjected to analysis. So aliquot kay I think usually ma-encounter ni nato sa volumetric method of analysis. And lastly, we have blank. It is a sample that contains all the components of the matrix except the analyte. So a blank kanang if in terms ni sa experiment, I think it is considered as the negative controlled group. Yeah, aside from that, as what I have searched, kay a blank is usually used to calibrate mga instruments, for example, ang spectrophotometer. And with that, kanang i-search lang ninyo kung unsa gyud kanang how the blank plays its part in the calibration of a spectrophotometer. Kay as what I have searched kay ang blank daw kanang ang una daw di ba gamit siya as pang-calibrate sa spectrophotometer. So siya ang una i-basa sa spectrophotometer before ang katong sample na gyud. And i-search lang ninyo guys kung unsay kuan gyud niya. And there are different types of blanks po di ay, so pwede po na ninyo i-search. Okay, so analytical techniques. So we have different analytical techniques. So we have gravimetry, we have titrimetry, spectroscopy, mass spectrometry, chromatography, and electrochemical analysis. So naa ni siya lahi-lahi na gi-analyze na methods na ay pamaagi sa pag-analyze og sample kani siya. And pero sa karon kay I will focus on kanang gravimetry. So for gravimetry or gravimetric method of analysis, the property measured is actually the weight of pure analyte or compound of known stoichiometry. So ang weight sa pure analyte. And example of which is katong analysis of soluble salts. I think mao ni ang ato ang na-encounter or gi-experimentan katong pag analytical chem nato na lab. And also another example kay analysis of an ore na sa mga mining industries. And lastly, analysis of limestone or dolomite. So here are the principal steps in gravimetric method. So first, weighing of the sample. Second, dissolving of the sample to an appropriate solvent. Now, third, precipitation of analyte. Fourth is the digestion. Fifth is the isolation of the substance via filtration and washing. And lastly, sixth pa di ay, drying or ignition. And lastly, the 7th step is the determining the weight or percentage of analyte. So actually guys, akong nakatunan sa quantum kay naa day 0th step ana, so pinaka-initial gyud daw hidden step. So that before sa 0 step, actually kanang mag-weigh sa dawta sa ato ang crucible, mao na 0th step, and mabaw-on na nato na unsa important sa pag-weigh sa crucible dinha sa mga last step. So ato i-go through again. So weighing of sample ato siya. So with that makabaw ta sa weight sa ato ang sample, and that is useful sa ato ang computation later on. After which i-dissolve na to atong sample sa appropriate solvent. And aside from that, after gisod na to tong sample sa solvent, nihuman dayon na pagyud na i-add na precipitating agent to induce precipitation of the analyte, which is the mona 3rd step. After which biyaan na nato kana na solution, and thus it undergoes digestion. So sa digestion na part, dinha na mag-form og mga crystals, or kanang mag-clump, mag-coagulate na ang ato ang mga precipitate, so mudagko na siya. Thus after ana, i-isolate nato to ang ato ang mga precipitate via filtration and washing pod, kay ato man na siyang hugasan gamay og distilled water. Okay. Yeah, after which na-isolate na nato ato ang precipitate, isudayon nato siya sa oven. Naka-remember mo ato na ato ang filter paper atong gisod sa oven. Yeah. Pero sa ato ang kanang analytical chem na experiment, kutob beta dito kay wala man tay, di man ta ka-undergo og ignition. Pero usually daw, or I think dapat tagyud daw to na i-undergo og ignition. So after drying kay ignition dayon. Sa ignition na part kay ato i-separate atong precipitate, ibutang siya sa crucible. Yeah, ipa-ignite siya. So the purpose of ignition is to kanang sa drying manggod, dili tanan water ang ni-evaporate. Napagyud na kanang gagmay na mga water na na-stuck din hasud sa atong precipitate. So the purpose of ignition kay para gyud wa tanan moisture nato sa ato ang precipitate. So after which, mo na to, after ignition, we have a crucible na with our dry na precipitate. Dry na gyud na precipitate. Then human dayon, by that, makadetermine na ta sa atong weight sa ato ang analyte by let me remind you, katong first na step, katong pagkuha sa weight sa crucible. So i-minus ra nato ang katong mass sa crucible plus katong precipitate, i-minus nato sa mass sa crucible sa atong nakuha originally sa 0th step. Okay? So with that, makakuha na ta sa weight sa ato ang analyte. Then, mo gamit dayon ta, we can also know the percentage of the analyte using this kanang formula. So mao ni siya. We have %x. So x, where x is our analyte or compound with known stoichiometry, it is equals to mass of our precipitate times quantity molar mass x over molar mass ppt over mass of sample times 100. And ang kanang quantity din kanang gisud parenthesis, that is actually very important part of our kanang gravimetric na calculation. It is known as the gravimetric factor. It represents the weight of the desired constituent equivalent to 1 unit weight of a given substance. So para nako kani siyang gravimetric method kay gravimetric factor relationship siya between sa imuhang analyte nimo ug sa imong precipitate. So para masabtan pagyud nato ni, let us see this kanang examples. So as what I have said, kanang relationship siya sa imong analyte ug sa imong precipitate. Like for example, ang atong analyte atong gusto mabaw-an, example number 1, atong gusto mabaw-an kay ang sulfur. Nya ato ang precipitate kay ang barium sulfate. So ato ang X ato kay mo na ang kanang sulfur. Nya atong precipitate kay BaSO4. So ang gravimetric factor kay nag-show sa relationship anang duha. Okay? So, to get the gravimetric factor, kay for number 1, we have sulfur og in BaSO4. So, to get a gravimetric factor, it is equivalent to the molar mass of sulfur times N over molar mass BaSO4. Then, our N there, it is actually the murag stoichiometric ratio gani niya. I think familiar naman ta ani, right? Stoichiometric ratio siya between sa sulfur ug sa BaSO4. So ako ang pag-think ani kay pila ka buok mole sa sulfur ang nasa BaSO4 niya. At I think makita ra man gyud nato dinha sa iyahang kanang sa formula sa barium sulfate. So as we can see, there is only for 1 mole sa BaSO4, there is 1 mole of sulfur. That's why ang N niya is equals to 1. Okay? So, mao na, computing for the GF, the molar mass of sulfur kay 32.06 times 1, nani times 1 din ha, over 233.4. So, mao na, ang gravimetric factor nato kay 0.1374. Okay? So, another example is FeO in Fe2O3. So, let's get the ratio. FeO, iron oxide over iron oxide. Iron oxide ni sa taas kay katuning 2 plus niya, ang kaning sa ubos kay katong 3 plus. It is equal to the molar mass of the FeO times N over molar mass of the Fe2O3. Then ang N ana, we can actually get the N using the stoichiometric ratio between sa FeO ug sa Fe2O3. So, here makita ninyo ang kanang reaction. So, for 1 mole of Fe2O3, we can actually get 2 moles of FeO. So, mao na N is equals to 2 mole of FeO over 1 mole of Fe2O3. So, mao na atong N kay 2. Okay? Then, mao na, ato i-multiply ang 2 sa molar mass sa FeO. Yeah, over siya sa molar mass sa Fe2O3. That's why mao ni siya yung stoichiometric ratio. Ay, sa iyahang gravimetric factor. Okay? Then, lastly, we have Mn in Mn3O4. So, ang ratio So, for our gravimetric factor, kay ang ratio sa Mn over Mn3O4. So, it is equals to the molar mass of the Mn times N over the molar mass of Mn3O4. So, our N there, it is, pila man ka Mn ang nasa Mn3O4. Di ba tulo ka buok? So, mao na atong N kay 3. Okay? So, computing for the gravimetric factor, times yun natog 3 ang molar mass sa Mn. So, mao ni 164.7 over 228.8. Mao na ang GF sa ato ang Mn in Mn3O4. Okay? Sorry. So, let's have a sample problem para ma-apply nato ang ato ang katong formula for finding percent X or the percent analyte, and ma-apply pod nato ang ato ang gravimetric factor. Okay? So, here's our sample problem. So, we have an iron ore was analyzed by dissolving a 1.1324 gram sample in concentrated HCl. The resulting solution was diluted with water, and the iron 3 was precipitated as the hydrous oxide. By the addition of an NH3, ammonia. After filtration and washing, the residue was ignited at a high temperature to give 0.5394 grams of pure Fe2O3. Calculate A, the percent Fe, and B, the percent Fe3O4 in the sample. So first, let us kanang identify the given. So we have the mass of sample, which is equivalent to 1.1324 grams. We also have the mass of the precipitate, which is equivalent to 0.5394 grams Fe2O3. And we are also given the molar masses of the kanang mga sa atong mga components. Molar mass of Fe, we have molar mass of Fe2O3, and we have molar mass of Fe3O4 na sa kaning sample problem. So let's proceed with the solution. So for computing the percent iron, so first let us determine the gravimetric factor. Let us first determine the NDI. So pila man ka iron ang naa sa Fe2O3? Di ba duha? So mao na tong N kay 2. Okay? Then human dayon our gravimetric factor kay katong molar mass Fe times 2 kay N na to is equivalent to 2 over molar mass of Fe2O3. So ako na lang gidiretso din ha guys sa formula. Ano lang nako gilahi gyud ang gravimetric factor. So mao na to which ato na lang gyud direct substitution na ni tanan. So we are given naman with the mass of Fe2O3 which is equivalent to 0.5394. Ato na i-plot na human dayon we also have N 2 which is equal to 2. We have the molar mass of iron given na po dito sa problem which is equivalent to 55.847 gram per mole. Then we also have the molar mass of Fe2O3 which is equivalent to 159.69 gram per mole. Then divide all by the mass of sample which is equivalent to 1.1324 grams. Now times 100, mo na ito makuha na percent iron is equals to 33.32%. Okay? Then next, last kay B, compute for the percent Fe3O4. So for this, for determining the N, let us look at the reaction na sa reaction kanina reaction. So for 3 moles of Fe2O3 kay makakuha, so for 3 moles of Fe2O3 kay maka-create tag 2 moles of Fe3O4 plus 1/2 O2. So mao na by that stoichiometric na ratio kay maka-compute sa for N. Then with that kay mao na 2 moles of Fe3O4 makakuha ta og 2 moles na Fe3O4 by 3 moles of Fe2O3. So mao na atong stoichiometric ratio kay 2/3. Okay? Then for the percent Fe2O3 na din ni guys, dili na ni percent iron. Ato lang i-plot ang ato ang mga given and our new na GF which is equivalent to 2/3 times molar mass of Fe3O4 over molar mass of Fe2O3. Then divided ang tanan to 1.1324 and multiply by 100. Mao na ato makuha na percent Fe3O4 is equivalent to 46.04%. So that is all. Mao na ato ang pagkuha sa percent na kung unsa tong gusto na makuha na percent analyte or kung unsa ang gi-ask sa problem. So we can create kanang reactions para makakabaw ta sa stoichiometric ratio. Ingana. Then mao ni akong references sa SCOG. Katoday na problem guys, gikan na sa SCOG, Fundamentals of Analytical Chemistry 9th edition, and uban na mga terms and uban na mga terms o kuan kay gikan sa quantitative chemical analysis katong ka reference ni siya ni Ma'am Lariosa. So mato, thank you.